All right, welcome back, everyone. We're going to continue with our material. All right, where we left off, we were talking about defecation as far as one of the functions of the digestive system. We mentioned, actually, you want to my glasses on real quick. We mentioned how there are four primary functions of the digestive system. We have ingestion, digestion, absorption, and defecation. Defecation is obviously just the end of this whole cycle, this whole process. It's to eliminate any residue, specifically things that are indigestible, so things that you cannot break down any further. And one thing that I did mention as a bit of like a preview was that your body does have methods to break this stuff down using bacteria. So we'll get into that as we continue progressing. Okay, so let's go through a little bit of the anatomy. This is really what the Quizlet was showing when I posted in Classroom, and also yesterday's video I kind of talked about that a little bit. But the entire digestive system can be summarized into what we call the alimentary canal. The alimentary canal has another name that you more commonly hear, especially in medicine, the gastrointestinal tract. So physicians that focus on the digestive system are usually referred to as GI physicians, so gastroenterologists. So these are people that literally anything from the mouth all the way to the anus, they have to be able to understand very well. So as I mentioned, starting in the mouth all the way through the pharynx, also known as the throat, the esophagus, which is the tube right behind the trachea, the stomach, small intestine, large intestine, and of course the anus itself is considered to be part of the large intestine, so it's all connected. And then as far as accessory organs, these are organs that help with the process. Everything excluding teeth and tongue. So the teeth and tongue obviously interact with food, right? They are necessary to help break food down. But these digestive glands that we see here, they do not interact with food directly, meaning they don't touch the food. They instead secrete enzymes to help break down food. So, for instance, the pancreas is considered one of these major digestive glands. The salivary glands, they secrete saliva, which will inevitably interact with food. So, the accessory organs just help with the process of breaking food down and moving food throughout the digestive system. All right, this is a great picture to focus on and just to get a better idea as try to learn on your time. I think this is an amazing job of showing on the left-hand side the more anatomically correct version of the digestive system. On the right-hand side, I like this diagram too because it kind of just strips everything apart. It makes it very bare bones. So let's start with the left just to get an idea of some of the anatomy. So of course, here we see the oral cavity, otherwise known as your mouth, right? The oral cavity is going to have a couple things that we should be aware of. First and foremost, we have 3 salivary glands. We don't learn necessarily the names of those glands in this chapter. We don't get too crazy with that as far as like submandibular, sublingual, all that type of stuff. We're good. We don't need to worry about that. As long as you know that in general, all 3 of these are considered salivary glands, we're fine. We, of course, have this large muscle-like tissue. It's not specifically a muscle, but it's like in that realm. The tongue plays a massive role in many things, including speech and obviously eating. And then we're also going to have the teeth in there as well. So we'll talk a little bit about that as we progress. So from the oral cavity, you're going to swallow food and it's going to pass through the pharynx. We learned all about the pharynx back in respiratory system, so that's not brand new. We're comfortable with that because we know that it's essential for breathing, so no problem. Same thing here. Food is going to travel down. The biggest difference is that the epiglottis, that structure found in the larynx, is now going to stay closed. If it stays closed, that prevents food from entering into your trachea, or liquid for that matter, which would obviously be a choking hazard. So now things are going to travel down the esophagus. Speaking of choking hazard, it can still be a choking hazard even if the epiglottis is closed. This is the entire reason why we chew our food. I know some of us like to eat our food a little fast and rapid and as if it's the last meal we're ever going to have. But if you don't chew your food enough, unfortunately, right around this area up here, near the beginning of the pharynx, food can get lodged. Not only can that obviously be uncomfortable and irritating, but if it's lodged enough, not even air can pass through there, and that's what causes choking. It's the entire reason why the Heimlich maneuver exists, to help force air out in order to expulse whatever might be trapped in there. So back to what we were mentioning, the esophagus, this long tube that goes behind the trachea. So you don't really feel the esophagus or anything like that. It goes all the way down until eventually it reaches this football-shaped structure. We all know this structure. We're all very familiar with it because when we're hungry, when we're maybe a little moody, when things aren't looking great, this organ loves to speak up, the stomach. It is a rather large organ. The amount that it can hold varies a little bit person to person. A lot of it honestly depends on how fast it can break food down. We'll get into all of that when we talk about the stomach more specifically. Here we're able to see what's called sphincters. These sphincters, I like to think of them like muscular doors. Their entire purpose is to constrict. And when they constrict, they're going to prevent any backflow. So for instance, this sphincter here that connects to the esophagus, it's going to prevent stomach acid from going up. If stomach acid goes up into the esophagus, that's what we commonly refer to as heartburn. It has nothing to do with the heart itself, although it feels like it because of the area in which your body's experiencing pain. But it's literal stomach acid coming up through the esophagus and melting away the inner tissue. The good news is that if you're someone who may suffer from heartburn, or you know someone who suffers from heartburn, the esophageal tissue can recover pretty well. But having regular amounts of heartburn, like a condition known as GERD, GERD, that's obviously a problem. It can cause permanent tissue and permanent scarring. This other sphincter down here, it just connects to the small intestine, which obviously helps to control when you move things from the stomach into the next organ. Now, before we move on, here are some accessory organs. Remember I mentioned we have these organs that help to break food down and move food through the digestive system, but they don't directly touch food? Well, here's our great examples. The liver, this massive organ that is incredibly powerful at filtration and cleaning your body and keeping you functional. Interestingly enough, if you only had a third of the liver, so let's say like something on the lines of here, if only roughly a third of the liver was still functional and healthy, you could recuperate the liver 100%. It is one of the best regenerative tissues that your body has, and the ability to just regrow. That is very rare for the body to do that. We know that our cells regrow every single day. That is pretty normal, but for it to regrow that much is substantial. You could theoretically donate part of your liver to someone who may be suffering from liver damage or liver failure, possible liver failure, and in theory, it could help recuperate their liver. It doesn't always work like that. Liver transplants are not always guaranteed, obviously, but this is an option. Right behind the liver, we have this tiny, tiny bladder-like structure called the gallbladder. It's always colored in this green color just because it has a very particular compound that it creates called bile. And then behind the stomach, you can kind of see it peek in its head a little bit there. We have a structure that is going to be horizontal, like right around the stomach region, like right a little lower than that, but right here. It's right behind the stomach. It's the pancreas. We learned about that back in endocrine system. And you might be wondering, wait, I thought we learned this organ already. We did. It just so happens that the pancreas is it's a complex organ. It's both endocrine and exocrine. So it secretes those hormones, which we learned about like with insulin and glucagon. And it also is responsible for secreting enzymes, which are necessary for the breakdown of our molecules and our nutrients. Well, if we follow the stomach, right, you'll notice that it eventually connects to this large maze-like structure. The small intestine, or as I like to joke, the not so small intestine. It is very long. It does not matter the size of the individual or the person. Every single human being, unless they've had a surgical procedure to cut their small intestine, which is something people do, it can be beneficial for weight loss in this instance. But every single human being has at least 20 feet worth of small intestine. It is like a fire hose coiled up all together inside of there. Connected to the small intestine, after you follow this long, long maze, and there's a reason why it's so long, as we'll learn. As you follow this long, long maze, you enter what I like to call the scarf of the small intestine, this massive tissue called the large intestine. The large intestine is nowhere near as long. It is much larger in size, especially in diameter and width, but it kind of rests itself, as you can tell. It starts at this bottom area and rests itself on the small intestine, eventually coiling back down and then inevitably ending at the end of the body, the anus, where the fecal matter will release. Here we can see everything I just mentioned just in a more straightforward method. If you eliminate all the twists and turns and the sphincters and all that stuff that we were mentioning, you can just tell that the digestive pathway, the gastrointestinal tract, the GI tract, alimentary canal, is just one long tube, literally. You start at the mouth, you end at the anus, it moves its way through. Yes, it takes time. It takes 4 or 6 hours, depending on how much you're eating, but it does take time to make its way from here all the way out. And that's the process we're going to be learning in detail in this unit. Let's start with the mouth. All right, so I talked about the mouth briefly back in skeletal system. So quarter 1, this is really reviewing some content we covered previously. What we mentioned back in skeletal system is that the teeth, all these sets of teeth that we have inside of our mouth, they're very similar to bone. They're bone-like, as we like to call them. But teeth are their own type of tissue. The reason why we mention that they're so similar to bone is not because they help with the creation of blood cells or anything like that. It's purely because their actual molecular structure is so dense and it lasts for so long that in the act of decomposition, so when we perish and our body starts to break down, which is purely natural, every single living organism has to go through this, the only things that are left over for a prolonged period of time is our bones and our teeth. Everything else about us goes away pretty fast, especially like outer organs like ears, nose, eyes, etc. Now let's get back to here. The oral cavity, otherwise known as the mouth, right? What we do in the oral cavity is a mixture of both mechanical and chemical digestion. Mechanical especially is very prevalent here, but the chemical digestion helps to start the process as far as breakdown of some of these massive macromolecules that we need to use for nourishment. The salivary glands. Remember how we mentioned we have a couple of them? We have one right behind the mouth, we have one right under the tongue, and then we're going to have another one near the mandible, so the jawbone as we refer to it. Their job is to secrete saliva. Saliva, as we know, helps to lubricate the food, but not only lubricate the food and make it easier to travel down the throat, it is also essential for the breakdown of what we call amylose. Amylose, if you remember our suffixes way back in macromolecules, anything ending in OSE was a sugar. Glucose, for instance, right? Amylose is just another type of sugar. We just happen to find amylose highly in our starches. So that can be like your breads and your rice and your pastas, etc. But the point of this enzyme, right? Because anytime ending in ASE, it's going to be an enzyme. The point of this enzyme is to help break down sugars. It's what I mentioned in our last video. If you chew on something long enough, especially something carb heavy, it eventually loses its texture very fast and it becomes more and more of like a mush. It's kind of disgusting to think about that, but that's kind of the whole point. It's making it so that it's much easier to travel its way down. Here's a nice verb that I'd like us to know for just basic terminology: mastication. Mastication is an anatomical name for chewing. Again, using some other languages really helps in these situations. So, for instance, I think of in Spanish, the verb masticar means to chew. So mastication, masticar, you can kind of see where things start to play together, especially with a lot of these Latin-based words. The tongue. As I mentioned, it's very muscular-esque. It's similar in the sense of how much control you have over it and how much strength it generates. Its main purpose with regards to the digestive system is to mix the food and form what we call a food ball. As I mentioned in our last video, the way that the tongue works is literally if you imagine you're working with wet clay and you're molding the wet clay into like a pot, for instance. Your tongue does that with the food you're eating by molding the food against the roof of your mouth and just shaping and turning the food until eventually we call it this food ball, also known as a bolus. That shape is purposeful. It's the easiest shape possible to travel down your esophagus and not get lodged or possibly create a choking hazard. How much time should you be chewing your food in order to prevent any sort of risk? The normal amount of time. It's not like you have to become super meticulous about like, okay, let me think, 5 seconds worth of chewing or anything like that. No, just eat your food normally, casually, assuming you're, have more food left to continue eating. I will say though, as we get into more of our like nutrition discussion, as far as like dietary stuff and healthier foods to be consuming, it is proven that for people that if they're looking to maintain a healthy weight or possibly lose weight, if you eat slower, it has shown to give you benefits for losing weight. And the entire reason for that is if you eat slower, your body fills up faster, and thus you don't feel the need to eat as much. I'm sure I'm not the only one that's been in this position where you kind of eat with your eyes and you see this big plate ahead of you and you're like, oh man, I'm so starving. Yum, 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 yum. You keep eating, and then eventually you have that moment of no return. You've crossed the threshold and you're so full because of how much you ate and your stomach's bloated. That's not exactly a great feeling. So if you do spend a little bit more time, and honestly, it doesn't necessarily have to be timing yourself. It could just be like, especially in a social interaction, eat a couple bites of whatever you're eating, put down your fork for a little bit, and engage in conversation. That's actually very popular in amongst a lot of these European countries as far as their standard method of eating. Here in the US, we like to be a little bit more brutish, I guess is the word to use, where we like to eat our food and talk at the same time and feel like it's a race to eat as soon as possible. It could help out, just a little theory there. But last thing I do want to mention as far as the mouth before we finish today's video, we know, especially if you've been to a dentist before, that you have different types of teeth. The reason why we have this different type of teeth is purely evolutionary. So for instance, in the very front, we have what's called our incisors. I'm not going to necessarily get too crazy with this for testing, but it's worth talking about, right? The incisors, their entire job is to help tear. So some animals that do this amazing job of tearing flesh off of the animals they're hunting, they have these incredible sharp incisors. Then we have a set of teeth that a lot of us are very familiar with, especially if you've seen any sort of show with like vampires, because they have these like hyperbolic canines. But the canine teeth, we find them on the top, we find them on the bottom. The canine teeth are helpful for this gripping action. So they help with the grip and tearing in the left to right method. Obviously, more wild animals have sharper canines than we do, and some animals even have more than just their two sets of two canines. And then finally, a very important set of teeth that is unique, not just to us, but to other omnivores, and specifically herbivores. We have these teeth in the back here, the molars. The molars are rounded. They don't have that sharp edge. So the reason why they're rounded is in order to grind the food. Why is that an evolutionary thing? Well, if you think back to herbivores being a thing, like as far as their origination of herbivores versus your origination of carnivores, herbivores eat plants. Plants don't need this tearing action. So for instance, when you look at cows, it's kind of weird if you get a chance to look in their mouth, they just have molars surrounding their entire mouth. Because for them, all they need is something to grind something down. So for instance, when they consume like grass, for instance, it's going to be better for them to just break down the grass into this pud that's easier to swallow. So it's much better for that. And then eventually, when you had mammals like us that are omnivores, that we eat meat and plants, we kind of had a mixture of both. We still have these incisors, we still have these canines that are helpful for meat purposes and tearing. We don't really consume live animals like that, but you know what I mean, just meat that you could buy at a store. But we still have the molars, which are necessary for a lot of those veggies that we love to consume. So it is pretty interesting. Last thing I'll mention, you see on the back here how we have these wisdom teeth? This is purely a remnant, if you want to call it that, of our ancestry. When our previous species, or our previous evolution before Homo sapien, had a larger skull. So it made sense that they would have an extra set of teeth for chewing purposes. As we continued evolving and we got a little bit more smaller, and our skull especially got a little bit more condensed, we didn't need those teeth anymore. So what we notice is that for some people, they're born with these wisdom teeth that come in. And if they're born at such an angle, you can have wisdom teeth and there's no problem. There's no altercation with this. For many people, including myself, they'll grow in, especially around pubescence, a little post-pubescence, so like maybe into your 18, 19, 20 years of age, they'll grow in at an awkward angle. And unfortunately, they'll grow in at an angle that starts to affect the molars. So your dentist will notice that and say, hey, we got to do a surgical procedure to get them out. You get them removed. Does that affect your mouth at all? No. You'll have puffy cheeks like a chipmunk. It'll take some time to recover, but it is what it is. And then some people, they never even have their wisdom teeth form. It's a really interesting thing that is purely there as a reminder of our evolution from our previous background and our previous species that we used to be. Okay, so thanks for paying attention to this video, guys. Again, if you have any questions, feel free to ask me in Hangouts. As I send a message and remind a little earlier today, please make sure you're completing the Bellworks, because that is my main method of doing the attendance. And not only that, occasionally I do grade them, so I want to make sure you're good with that as well. All right, have a good day, guys.